All right, day 15. Let's continue on here in section 6.4. Remember, leading into this. So before in 6.2 and 6.3, we really focused on quadrilaterals and what it takes for them to be parallelograms. And we kind of went back and forth between their converses. So now we're going to take these parallelograms and we're going to look at special parallelograms. So the first one we come to is a rhombus. So a rhombus, it's a parallelogram with 4 congruent sides. Now, when you guys think of these, of something that has 4 congruent sides, you're probably thinking of something else. I'm not going to say that name because we'll say it down below, but right now you should be thinking rhombus for a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And then if we bring those two ideas together, we get a square. Square, which actually is one of the simplest shapes that we learn, turns out to be not one of the most complex, but it's actually a combination of these special parallelograms. So a square is a parallelogram with 4 congruent sides. So that's the rhombus side of it. And it has 4 right angles. So that's the rectangle side of it. So it is both rhombus and rectangle. Half rectangle, half rhombus. Maybe they should have came up with a better name than a square for a hybrid shape like that. So we have a little Venn diagram down here below that basically just shows rhombus, rectangle, and there's the square, which is the overlap of those properties. All right, down below we have probably one of the worst diagrams we can have right now. So it says we have parallelogram ABCD, which is a rhombus, which I believe is in here. And the only thing they give us, so is it a rhombus, is it a rectangle, or is it a square? And the only thing they give us is that right angle marking. And we know if it's a parallelogram, if we think back to the previous section, if that's 90 degrees, it has to be supplementary with this. So it means this is 90, and opposite angles are congruent. So all 4 of those are 90. We don't know anything about the sides, so right now it's a rectangle. Because we only know that there are 4 right angles. And that's all we know. All right, so we have some theorems. If a parallelogram is a rhombus, then its diagonals are perpendicular. So that means that AC is perpendicular to BD. Theorem 614, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So not only is that perpendicular, whoops, 1, 2, 3, 4, 5, 6, 7, 8. That means angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 is congruent to angle 6, and angle 7 is congruent to angle 8. So what are the measures of the numbered angles in rhombus ABCD? So if this is 58, that means this is 58. We know this is 90. So measure of angle 1 is 90. Well, that leads back to theorem 613. We know 3 and 2 are equal or congruent. But remember, this rhombus means it is a parallelogram, which means these are parallel. Which means these two, oops, I'm sorry, which means 3 is 58. Those are alternate interior angles. And then the measure of angle 2 equals 58, theorem 614, because it's a bisector. And then we know that measure of angle 4 plus 90, let's do it this way, plus the measure of angle 1 plus the measure of angle 3 have to be 180. That's theorem 311. So the measure of angle 4 equals 180 minus 90 minus 58, which is 32 degrees. Notice what happened just right there. Yes, these are bisected, but these are opposite, so these are actually all four the same. And that'll always be the case in a rhombus. And piggybacking right off of that idea, that means that the measure of angle 3 equals the measure of angle 4, which equals the measure of angle 1, which equals the measure of angle 2. So all four of those are equal. So that means 104 plus the measure of angle 1 plus the measure of angle 2 equals 180. These are actually the same thing. So if I can just figure out what these two add up to be, which is the measure of angle 1 plus the measure of angle 2, has to equal 76. This is basically saying x, and this is basically saying 2x, which is much more algebraic. And then divide both sides by 2. X equals 38. So it means they are all 38. All right, theorem 615. If a parallelogram is a rectangle, then its diagonals are congruent. Remember, a rectangle is a parallelogram, but it is not a rhombus necessarily. So that means we have this, and we have this. That means AC is congruent to BD.
Okay, I found.
So in rectangle RSBF, SF is 2x plus 15. RB is 5x minus 12. So they are diagonals in a rectangle, which means they should be congruent to each other. So 2x plus 15 equals 5x minus 12. I'm going to take the 2x over here, the 12 to the other side. 27 equals 3x, x equals 9. So that means SF equals 2 times 9 plus 15. Which is 18 plus 15, which is 33. And just to double check that, we have RB, which equals 5 times 9, which is 45, minus 12, which is 33. All right, now's a good time to pause that, try that yourself. But since they are diagonals of a rectangle, they should be equal to each other. And there you go. All right, take a look at that homework down below. Make sure you guys look at the exit ticket, email me, visit my office hours with any questions you have. Make sure you guys are getting any confusions clarified by contacting me before you get ready for the next step.